Alright guys, welcome. This is your lecture for Thursday night, April the 3rd, and it'll be hopefully pretty short and sweet. I'm anticipating it to be about 10 or 15 minutes. Before we begin though, I do want to show you or share one thing with you. I was reading over the weekend, article about Bitcoin, Litecoin, and Dogecoin. So Bitcoin probably being the one that you've recognized if you're following cryptocurrency at all. And it talks about the basics of cryptocurrency, so how it works. And there's something called a blockchain, which is pretty important as far as how cryptocurrency does work. And the concept of the blockchain is described much like a linked list. So just some real world application to what we're learning. If you're interested in reading this article, I've provided the link inside D12, the news section, so you can check that out. Okay. So as far as the actual class content then, tonight I've got exam 2 set up. It will be open on Thursday night at 7 p.m. It'll close at 10 p.m. You'll have 60 minutes, so I would have that started no later than 9 p.m. because I do believe that at 10 p.m., regardless of where you're at, it will close. It'll be 25 questions, a handful of multiple choice, true, false, and then a few more long answers than normal. So that's the reason for the shorter number of questions, or the few number of questions. As far as the content itself then, we'll be talking about a little bit of file I/O, so from the last quiz, and then structures and linked lists, so, and then type definitions and any of the other smaller topics that we talked about along the way. So a good point would be to go through those slides again, look at the the programs that we've worked on, and just make sure that you have a good understanding of what everything's doing. If you have any questions on any of the homework, I'm going to try to get the last lab graded before I take off on Wednesday. So if you have any questions on your grade or the feedback, please let me know. After you watch this, I'll be in the office until Wednesday afternoon, and then I'm taking off Wednesday night, and we'll be busy pretty much all day of Thursday. So I will do my best to answer if you have any questions before then, but please get a hold of me Monday or Tuesday or Wednesday during the day, just to help ensure that I can get back to you in a timely fashion. So with that, then I'm just going to run through some of the sample programs real quick. We've got the recording now, so as you're watching along, if you have any questions or maybe you didn't quite get this code in class, you can certainly pause it and take a look at that, make any modifications. I'm not going to spend too much time, we're not going to go in too much depth because we've gone through all this before, but certainly if something I say or doesn't make sense, or you're still a little uncertain about anything, please let me know and I can help provide some clarification. So going back to file I/O then, one of the first things that we talked about with our file I/O is the file pointer. So we create it as a pointer like we do any other type. We can assign it a null value, but then we use the file all uppercase to get the file pointer. When we open a file pointer, we use fopen, and there's two things that it can return. One is the stream to the file, the other is null, and this is a way of testing for that null pointer, the value of this pointer being null that was returned by fopen in one line of code. Regardless of how you test for it, it's always important to test for a null value, because if we weren't able to open the file, our program really can't continue on. With our use of fopen then, we have two arguments, right? So the first one is the file itself that we want to open, and the next one is the mode that we want to open it in. So both of these are critical. If we don't pass it the right file or the right location in the file system itself, then we won't open the stream, and then therefore the program won't work. But if we get the stream open, we also want to make sure that we open it in the right mode, because we can open it in a mode that can clear the contents of the file, and that may not be what you want to do. So make sure that if you're not familiar with the modes, they're on the slide deck, they're all over the internet. Just check that out and make sure you understand those. As far as reading then, once we get into it, there really isn't a whole lot we have to do as far as the functions go. There's just a couple that we've talked about and you probably used in this last lab. The first one was fscanf, so very similar to scanf, except that the first argument is our file pointer. Then we have the format specifiers, so the type of data that we're expecting to read in, and then where we want to store that data, so the names of the variables. Okay, since this fscanf is inside of our while loop, then we also want to test the condition. So we're saying that while fscanf, because fscanf will return an integer value, its return type is int, it returns an integer value based off the number of columns that it matches inside of that file stream that it's reading from. When it no longer matches anything, it returns a -1. EUF is a symbolic constant for -1. So as soon as we have a value that's equal to -1, then the loop breaks and our execution can continue past the loop. Otherwise, we just keep reading. So this is a while loop that'll read every single line in a file until it reaches the end of the file. Inside the loop, we simply print. Okay, we talked about using FEUF and some of the implications of that, or some of the nuances or caveats of using that. So I won't spend any time reviewing that here. Once we've read a file, our file pointer now points at the end of the file. So if we want to read it again in the same program, there's two things we can do. One is that we open that stream, close the stream and then open it up again. That will essentially reset that file pointer to the beginning of the file stream. Or we can call rewind. So you may or may not have used that inside of this last lab, depending on how you structure your reads from the file. Once we're done, just like malloc, we want to make sure we close that file pointer. So we call fclose and provide it the value of our file pointer. When we provide the value of the file pointer, it doesn't matter the state of the file pointer itself. We don't need to rewind before we close. We just need to make sure that we provide the file pointer and that it doesn't have a null value. Okay, so moving to writing to a file. Very similar program, very similar concepts. We use fopen just like we did in the previous program. The difference here is a couple. So we've got in our while loop, what this program does is it just allows our user to continuously enter in data that we want to be written to the file until they enter in the end of file. So a couple things. One is that we use the FEUF function. This is our standard in stream. Okay, so when we run a program, we get 3 streams automatically: standard in, standard out, and standard error. So we get standard in here. We use logical negation. So we say, while we're not at the end of the file, continue to loop. So we have our first scanf outside of that loop. That gets the value from our users. Then we use fprintf to print it to a file. Okay, as long as they didn't enter in the end of the file here, we can enter in the end of the file, or EOF, from the command line doing Control-D. As long as they didn't do that here, this condition will be true and will print off. fprintf, just like fscanf, and the first argument needs to be the file pointer. Then we have the format specifiers in the exact format that we want to write the content to the file. So if we want spaces, we need spaces. If we have new lines, we need new lines. And then we use the number of format specifiers that we used, the values or the variables that we want to provide in order to write that content. Okay, we're inside a loop, so we use scanf to get more data from our user. We loop back around, check the condition. If they didn't enter in the end of file, then we do it again. Okay. Once we're done, we need to make sure we call fclose and then the file pointer. So we saw in class that while we're running this program and we're calling fprintf, as long as we're inside of this loop, we didn't actually see any contents get written to the file. That's because as we're writing to the file, the program itself will start to store that content or that data into the buffer. And fclose, if you look at the definition, says that it forces all buffers to be flushed, all content to be written on the streams, and then it closes the stream. So you need to make sure that when you're doing fprintf, if you're not seeing content written to your file, either when you expect it to or at all, it might be because you're not calling fclosef on that file stream. All right, so those are probably all the big points as far as file I/O goes. Moving on, then I'll run through linked lists pretty quickly because again we've covered these I think extensively in class now. So if there's anything in general or specifically you have questions on this, just please let me know. Some of the basics then, talking about the structures that we need. Okay, so a linked list is a linear collection of self-referential structures. We declare a structure here, and I call it char node. Before I go any further, in the exam itself then, any references as far as to code inside of the questions about linked lists, I'll be referencing this code. So we'll have, unless I provide something specifically, I'll just be referencing this code. So we'll have a struct char node, we'll have one type definition. This type definition will not be a part of our code that I would use. We'll have a print list and an insert function. Okay, and whether or not your insert function maintains a sort order or not, it doesn't matter. We still have the insert function and it behaves as we've talked about in class. Okay, so going back, linked list, it's a linear collection of self-referential structures. So the nodes is how we refer to each element or each value or each whatever inside of our linked list. We've been using two members. One member is a char for the data. We call that data. The next one is struct char node, and it's the next node member. So this is what makes the structure self-referential, because it's a pointer to a data type of the same that this structure is. So struct char node, and this is a struct char node. Okay, we talked about type definitions, so there'll be a couple questions on those. And type definitions just essentially create a synonym or a shortcut. So you say type def, the data type that you want to create a shortcut to, and then the value or the name, the synonym that you want to create. Okay, so now every time I use node in my program, that's just simply a shortcut for struct char node. We can create type definitions from other type definitions. So in this case here, if I wanted to say type def node is a pointer, well, this is node pointer is a pointer to node. Okay, we'd have to know what node is struct char node. So this essentially is the equivalent of struct char node pointer. Okay, and then we have two functions that we've talked about, print list and insert. Delete we'll talk about in 2 weeks then, when we get back together and meet it in class. For print list, it's just one argument, pointer to a node. For insert function, we add a pointer to a pointer, so 2 levels of indirection. 2 levels of indirection are indicated by the fact that we use 2 pointers or 2 asterisk characters. And then the second argument is our char value. So looking at this insert function, we know, or we talked about in class, that I'm always just going to assume that we're going to pass the root memory address here, so the root of our linked list, and then this is simply whatever value that we want to insert. We've talked about 2 versions of this. The first version just simply started at the root node and it iterated until it found the last node and then appended a new node to it. The second version that we talked about would insert or maintain some sort of a sort order. Because we're using chars, we just simply maintain alphabetic order ascending, I believe. So A, B, C, D, E, F, and whatever. Okay, looking at the main function then, we have this first. We talked about creating, let's just get rid of some of this code here for a second. When we first started talking about linked lists, we talked about doing this essentially in a manual fashion. That is, that we created a pointer to a root, or a pointer to a node. I called it root just because that, at least for me, it helps conceptually to indicate that this is the very beginning of our linked list. We malloc the memory. Once we had the memory mallocked, then we updated the data member to the value that we wanted to store there, and the next node member equal to null. We use the null value in the next node member to ensure that we can find the end of our linked list. Now we created a second node, called it second, it's pointer to a node. We malloc the memory, we update the data member to whatever value that we want to store, and we set its next node member equal to null. Finally, we have to link the root node to the second node. And we do that by saying second is our new node. Its next node member needs to stay null because it's going to be the end of the linked list. But the next node member from the root node needs to now point to the second node. So root's next node member equals second. And now if we called print list, it would print off B and C. Okay, so it's very important though that if we're looking at doing this manually and creating nodes and linking them together, that we look at which members, so which variables, which pointers and their members that we're accessing, and then we're doing it in the correct order. If we add a third node, then we'd have to make sure that we set the second node's next node member equal to the third node's value, memory address. So just pay close attention to this manual structure and what's being done there. Okay, so that works, but it works better if we create a function. So that's where the insert function comes into play. We said that now we can create a root node and we can use that value to pass to our insert function, and now we can just call insert using our root node and then whatever value. Depending on the version of the insert function, this will either be maintained in sort order, so it would still be A, B, C, D, or it'll be B, C, D, A, and simply append the new nodes on to the end of the linked list. Either way, for the exam, doesn't really matter, whichever version you have working and you're comfortable with. Important thing is that we took all of the steps here, all the logic that we had in creating a new node and appending it to, or adding it to our linked list, again, whether it was to the end or in some sort of a sort order, and we encapsulate it inside of this insert function. So this example now, with the second node being commented out, just delete it, this now creates a linked list with 4 nodes. So we have our root node, then we insert a second, a third, and a fourth. So if we call the print list function with the root of this linked list, we print out 4 values. Okay, this next chunk of code, this was just from our talk about concatenating or merging the linked list, so from the in-class assignment. I don't ask anything specific about this, so you really don't have to worry about it, but here is the code just in case you didn't get a chance to look at it in class. Okay, now the print list, so it accepts or expects a pointer value. First we check if it's null, and then we just simply iterate over the linked list, printing off the data member, so those char values, until we reach the end of the linked list. Okay, make sure you understand what's happening here. We talked about how this is the foundation for our functions that we've talked about. So print list, the insert with a sort order, and then when we talk about delete, we'll use the same structure throughout. Make sure you understand what is the value of current pointer once this loop terminates, once this condition is now no longer true but is false. And then we get here and we're done. So when we're printing off the list, we don't care about the state of the list. We don't maintain any pointers. When we look at the insert function, you'll see that we have the current pointer and the previous pointer, because once this loop breaks, we've found the end of the linked list, we've printed off the last data member, and the function just needs to return. Alright, so here's our insert function. This maintains a sort order. We have the new pointer, previous pointer, current pointer. Okay, new pointer is just that. We're creating a new pointer based off of the value that we're passing into the function and the root node. Here we set up our pointers then. So after we update the data member and update this next member equal to null, we set up the pointers that we have. So we set previous pointer equal to null and current pointer equal to the start pointer. And now we have our loop. Okay, so this is the same condition that we looked for in our print list function. That is that once current pointer is equal to null, we found the end of our linked list. So if that's the case, and this condition was never false, then that means we've reached the end of the linked list. Otherwise, this is the condition that's applying the sort order. So we're saying that while the value is less than the current pointer's data member, and this will maintain if we have BCD and we want to insert A, that A becomes the new root node. Okay, we went through that in class, and so make sure you understand and you're clear with what we're doing with previous pointer and current pointer as we walk through the linked list. So at the point in time that this loop terminates, with this version, there could be one of two conditions. If we get rid of that, let's just say that we're only worried about when we find the end of the linked list. What would be the value of current pointer when this terminates? Again, okay, same thing we talked about with the print list function. If we add that condition back in, okay, when this loop terminates, it doesn't mean that we're at the end of the linked list. It just means that we found the nodes where we want to insert our new node into, in between. And so the previous pointer and the current pointer will represent that. Went through in class as well. Make sure you understand when you look at this if-else branch, what happens, excuse me, what is this doing? I guess what is this code actually doing? What does it mean? What part of, so what is this code doing? What does it mean when we enter this branch of code or execute this branch of code? And then what does it mean when we execute this one or go down here? What is this actually doing? What is these two lines of code doing? They're not the same thing. This is doing something very specific. Lines 142 and 143. So just make sure you understand that or have an idea. And if you don't, let me know and I can help you out. Otherwise, that's it. There's the delete function. We'll talk about that in a couple weeks. So again, majority of the quiz or the exam will be on linked lists. It'll be a handful of multiple choice true false and then some long answer. So with the long answer, make sure that if you have any trouble with them saving, if for some reason it stops saving, make sure that whatever did not get saved if you have a long answer, save it, copy it, and paste it into something, WordPad, Notepad, whatever, and then just close the browser and enter back into it. As long as the time hasn't expired, you'll be able to exit out, enter back into it, and then it should start working again. If you do that and you didn't save anything, then you just lose it and you'll have to do it over again. So avoid that frustration, and I know that it happens a lot. So outside of that, again, let me know if you have any questions, and hope everyone has a good week, and I'll see you guys in a couple weeks.